Positive lightning, the bolt that hits you on a sunny day, from a storm you cannot even see. Blue sky overhead, the nearest storm kilometers away on the horizon. You feel safe. That is exactly the mistake. Most lightning leaves the base of the cloud. Positive lightning launches from the very top of the storm, travels sideways through clear air for up to 40 kilometers, and lands with no warning. Forecasters call it a bolt from the blue, and it does not play fair. A normal bolt carries around 30,000 amps. A positive bolt can hit 400,000. 10 times the current, up to 1,000,000,000 volts, 5 times hotter than the surface of the sun. It does not shock you. It starts a fire the instant it lands. Fewer than 1 in 10 strikes are positive, but these are the ones that reach out of a clear sky and kill people who were sure the storm had passed. Quick thing, most of you are not subscribed yet. If this hooks you, tap subscribe, it is free and takes a second. And stay to the end, because I am leaving a question only people who watched all of it can answer. Now, if a bolt from a clear sky rattles you, wait until you meet the one that does not fall at all. It climbs. Upward lightning, the moment the ground shoots back. Everyone knows the rule, lightning falls from the sky. The people in the penthouse assume the rod on the roof handles it, and the storm overhead is somebody else's problem. Then physics sends the bill. When a storm passes close to a tall structure, usually above 100 meters, the field at the tip gets so intense that the building fires first. A channel of plasma launches off the spire at nearly 300,000 kilometers per hour, reaching up to grab the cloud before the cloud can reach down. You thought you built a skyscraper. You actually built an electric harpoon aimed at the sky. And if electricity climbing upward is strange, wait until the wind smears a bolt across the horizon. Ball lightning, electricity that grows a body and walks into your house. For centuries, people who saw a glowing orb drift through a wall swore it was a ghost or a UFO in the kitchen. They got called liars. Science just called it impossible. Then, in 2012, a team in China caught one on camera by accident and recorded its spectrum for the first time. The ball was full of silicon, iron, and calcium, the exact elements in the soil where the bolt had struck. The leading idea, lightning hits the ground, vaporizes the silica in the dirt, and the vapor condenses into a floating, burning ball. It can be the size of a grapefruit. It drifts. It passes through closed windows without cracking the glass. It lasts several seconds, an eternity for electricity, then either fades out or detonates like a grenade. 1 in 20 people say they have seen one, and science still cannot fully explain what they saw. But if a ball you can see is unsettling, wait until the wind turns a single bolt into a barcode. Ribbon lightning, the glitch in the sky's video feed. You know how a night photo comes out smeared when your hand shakes? The atmosphere stutters too, and it prints the result across the horizon. A bolt is almost never a single shot. It is a burst of 3 or 4 strokes firing down the same channel in about 40 milliseconds. Ribbon lightning happens when a crosswind near 100 kilometers per hour shoves that channel sideways between one stroke and the next. Each stroke lands in a slightly different spot, and your eye catches them all at once as parallel glowing ribbons. It is the only time you will watch the wind pick up raw electricity and rearrange it like furniture. And if the wind stretching a bolt bends your brain, hold on for the night the sky hangs up a necklace of pearls. Bead lightning. When the bolt dies, it leaves jewelry behind. A witness swears the sky just fired a string of defective fireworks or broke into a line of little floating lights. When the main stroke, blazing at around 30,000 degrees Celsius, shuts off, the thin plasma channel, only about 3 centimeters wide, does not cool evenly. A few superheated pockets keep glowing tens of milliseconds longer than the rest. The dark swallows the gaps between them. What is left is a broken line of glowing beads, strung along 5 kilometers of sky where the bolt used to be. It is one of the rarest forms of lightning there is. For a few dozen milliseconds, a bolt stops being a line and becomes a necklace. But at least that one keeps its distance. The next one crawls onto metal and clings to it. St. Elmo's fire, the blue flame that is not fire, sitting on the wing of your plane. Picture cruising at 10,000 meters when the cockpit windshield lights up with dancing blue and violet flames. The nervous passenger starts praying, sure the wing is melting or the plane flew somewhere haunted. Relax, nothing is burning. When an aircraft or a ship's mast pushes through heavily charged air, the field at the sharp metal points can hit 30,000 volts per centimeter. That is enough to tear electrons off the nitrogen in the air and turn it into pure plasma, the fourth state of matter. It glows blue and hisses. It does not burn you. It is nature's neon sign, quietly announcing that a real strike might be seconds away. And if plasma clinging to metal gives you chills, wait for lightning born with no cloud at all inside a volcano. Volcanic lightning, a thunderstorm that does not need a cloud, just an eruption. You watch a volcano blow its top from a safe distance and assume the danger is the lava. Then the ash column starts flickering and the eruption grows its own electrical storm. They call it a dirty thunderstorm. As the volcano fires ash, rock, and gas skyward, the particles smash and grind against each other. That friction strips electrons and builds a massive static charge. The same physics as rubbing a balloon on your hair, scaled up to a mountain. When it gets big enough, it discharges as lightning right inside the plume. Roughly 1 in 3 eruptions sparks it. The Romans wrote it down during Vesuvius in the year 79. It is the planet reminding you it can build a thunderstorm out of a mountain, no rain required. And if that sounds like the ceiling of what is possible, the last 3 fire the other way, straight up toward space. Sprites, the red jellyfish floating above the storm. Everyone on the ground stares at the flooded street and the bolts hitting the field. Nobody looks up high enough to catch the light show 80 kilometers above their umbrella. When a powerful positive bolt hits the ground, it can trigger a burst of red light far up in the mesosphere, between 50 and 90 kilometers high, way above where any normal cloud lives. Sprites glow red, sprawl into shapes people call jellyfish or floating carrots, and vanish in a few thousandths of a second. They were pilot folklore until 1989, when a camera finally caught one by accident. For 100 years, pilots who reported them were ignored. Turns out they were watching the roof of the sky catch fire. Sprites bloom downward. The next one does the opposite, firing a jet up out of the storm. Blue jets. The storm firing a flare at the edge of space. From below, a storm looks like a solid ceiling. You would never guess the top is leaking, launching narrow blue cones straight up off its peak. A blue jet erupts from the top of a thundercloud and climbs in a slim cone, reaching about 40 to 50 kilometers before it fizzles out. It burns blue because at that altitude, the discharge lights up nitrogen a different color than the red glow higher up. Each one lasts a couple tenths of a second. While everyone films the rain, the storm is shooting blue flares at the stratosphere out of the top of its head. Gigantic jet, the lightning that plugs the clouds straight into space. We have gone from a bolt on a sunny beach all the way to the top of the atmosphere. This is the one that refuses to stop climbing. A gigantic jet starts as a discharge inside a thundercloud, but instead of hitting the ground or fizzling like a blue jet, its channel escapes upward and keeps going, all the way to the ionosphere, up to 90 kilometers high. It is the rarest and one of the brightest of them all, seen mostly over ocean storms, and it lasts nearly a full second, an impossibly long time for lightning. It changes color as it rises, blue at the bottom, red at the top, stitching the two halves of the sky together. Ordinary lightning connects a cloud to the ground. This one connects a cloud to space. For 1 full second, the whole atmosphere becomes a single wire running from the storm to the stars. Now the question I promised. Which one of these can kill you on a perfectly clear day from a storm so far off you cannot even hear the thunder? Drop your answer in the comments and tell me which phenomenon I should cover next.